This video cover about overall equipment effectiveness or OEE. This measurement is really common in manufacturing industry. So in this video, I'll explain about how to calculate availability, performance and quality and overall equipment effectiveness. We've got this data. There are two processes: casting, forging and CNC machining. The work hours is 8 hours per shift. The number of work hours is 2 until 3, depending on the process. And then there is also break per shift. The total production part, as you can see on the table. There is also standard cycle time or floor-to-floor time. Okay, there is actual cycle time. This one is cycle time calculated or timed by stopwatch. And then there's also changeover, minutes per day, corrective maintenance, minutes per day, and there is also scrap, rework, and good finish part. From this given data, we can calculate availability time. So to calculate availability time, first, we need to calculate the total time. Make it as minutes. So 8 hours become 480. Okay, this one is given. And then break, as the previously shown, is 30 minutes for every process. And then we can calculate the load time. Basically, just deducted total time by break. We've got 450. Okay, this one A divided by B, and that number of work shift. Okay, this one is given 2 to 3, and then we can calculate total load time. Basically, just multiply this, the LT multiplied by C. Alright, we got 900, and then the changeover is given as well, corrective maintenance given as previously, and then we can calculate availability time. Basically, the total load time deducted by this whole. We got 790. Okay, and then we can calculate the availability ratio. Basically, the AT, this one, divided by LT, the total load time. Okay. As you can see, for each process, I think the lowest is forging. And then for performance, basically this one standard cycle time or FTF. This one is given. Production is also given. And then we can calculate the performance rating. Basically, multiply the FTF multiplied by F, and then divided by availability time. We've got this one. Okay, and then after that we can get real cycle time. So for real cycle time, we can basically add this one, availability time, divided by production time, this one. Okay, so availability time divided by production time, and then we have calculate actual cycle time. This one is given. And then small stoppages, which is real cycle time deducted by actual cycle time. We got small stoppages. And then how do we get speed loss time? Basically, the actual cycle time deducted by standard cycle time or FTF. Okay, and then we can calculate part losses, how many parts that we lost. So basically, this one, the total of some small stoppages plus speed losses divided by FTF, and then multiplied by production. This one, we've got part losses for each process. And then for quality is basically production is given, scrap is also given, report is also given, good finish part is also given. We can just find quality ratio. Basically, the good part divided by the total production. We've got this one. And then for OEE, we just multiply every ratio, availability ratio, performance, availability multiplied by performance ratio, and then the last one, quality ratio. Then we can get OEE. Okay, as you can see, the lowest is casting and the highest is CNC. Thank you.